Let's suppose Sarah purchases only one good, hamburgers. So H is going to be the number of hamburgers she buys in a week. We'll give her a particular utility function, and it's going to be utility is the square root of the number of hamburgers she buys. So let's go ahead and graph her total utility function. On the vertical axis, we're going to have total utility as a function of hamburgers, and on the horizontal axis, we're going to have the number of hamburgers. So here's our functional form, and we're just going to plug in different numbers for hamburger. So we'll start with 0. The utility she gets when she buys 0 hamburgers is the square root of 0, or 0. We can plot that point. The utility she gets when she purchases 1 hamburger is the square root of 1, or 1. We can plot that point. The utility she gets when she buys 2 hamburgers is 1.414. From 3 hamburgers is 1.732. For 4 hamburgers is 2. For 5 hamburgers is 2.236. We could keep going, but you see the trend here. What's left to do is connect all of those dots and label it UH for total utility. What we can see here is Sarah's preferences are complete. And what complete means is each value of hamburgers that's greater than 0 yields a value of utility. So we can actually rank these baskets. We also can see that Sarah's preferences are transitive. So here I've labeled 3 of the baskets. I've labeled when she buys 1 hamburger A, when she buys 4 hamburgers B, and when she buys 5 hamburgers C. We can tell that C is better than B because C yields a higher level of utility than B does. We can also look and see that B is preferred to A because B has a higher utility than A does. Transitive would tell us that C would also be preferred to A. And yes, looking at the graph, we do see that is true. We can also see that Sarah's preferences satisfy the more is better criteria. So the more hamburgers she buys, the more utility she gets.